Hi everyone. In the part 2 of the lecture 8, we consider the MOS structure. Comparison between the MOS structure and the parallel plate is made. It is shown that the semiconductor region makes a big difference. The MOS is the key structure in the microelectronics. The oxide layer is very thin. How thin is it? Its physical thickness is about a few nanometers, and its electrical thickness is even smaller. The semiconductor, in most cases silicon, is doped with impurities. When we want to use the electrons as charge carriers, the p-type dopants are introduced. On the other hand, when we want to use the holes, the n-type impurity atoms are doped. When the oxide thickness is Tox and its permittivity is epsilon ox, is it a capacitor with the areal capacitance of epsilon ox over Tox? Of course, the answer would be no. In this video, we assume a MOS structure with a p-type substrate. However, the dual structure with an n-type substrate can be treated in a similar way. Then, what is the difference between the parallel plates and the MOS structure? Let's compare them. They can have the same dielectric layer. Note that silicon dioxide is also a dielectric material. Both structures can have the same metallic region for positive bias voltages, typically called the gate for the MOS structure. As we can see clearly, the only difference is the material connected to the ground. Is it a big deal? Assume that we have the same electric field in the dielectric layers. Its direction is shown in this figure. We have no electric field at a position deep inside metal or semiconductor. Therefore, it is certain that negative charges are required in both structures. How can these structures provide negative charges to compensate the electric field? It makes the main difference. As discussed in the part 1, the metal has many free electrons. Therefore, within a short distance, redistribution of free electrons can provide a negative charge. Then, how about the MOS structure? Do we have electrons in the p-type substrate? Of course not. Therefore, just like the p-n junction, the p-type substrate can provide a negative charge only by the depletion. Assume that the electric field at the interface, the surface electric field, is given by E sub s. According to the Gauss law, inside the depleted region, the electric field is decreased with a rate of minus QNA over epsilon silicon. By using this slope, we can express the depletion width WD as a function of the surface electric field. Within the depleted region, colored in the figure, we have no hole, we have no electron, and MOS structures are intentionally designed to be in such a situation at the zero gate voltage. In other words, with the zero gate voltage, we have no charge carrier near the semiconductor oxide interface. Now, let me increase the surface electric field by increasing the gate voltage. Then what will happen? it is easily expected that the depleted region becomes wider. Anything else? In the next video, we will study the MOS structure at a high gate voltage. Thank you.